All right, guys. I hope y'all are doing well. Today I will be talking about, or actually, I will be solving a Laplace transform problem. So this is a differential equation right here. This is a non-homogeneous differential equation right here, and with an initial condition, right? And I'll be solving this problem using Laplace transform. Okay, so one thing, this is just the first order, right? So it shouldn't be nothing too complicated. Just as long as you remember to apply this before you begin solving the problem. So this is the form for solving the Laplace transform of this particular first order differential equation, non-homogeneous equation, right? Okay, so you'll have S Laplace of y minus the initial condition, right? And so this is what you'll be using, right, to solve this particular right here solution, this equation, I'm sorry. So okay, let's go ahead and get started. I apologize for the handwriting, it's not the best, right? So okay, let's go ahead and get started. So we're gonna go ahead and apply Laplace to every single term on the equation. So let's go ahead and get started with that. Oops. So we have S Laplace of y minus the initial condition minus 8, right? So now we're gonna go ahead and get started, right? So Laplace of 3y equals the Laplace transform of 45t. So this is how you would first get started, right? Solving this Laplace transform. And so basically this is just the way. So as long as you get down to this step, it just turns into algebra from here pretty much. So as long as you can remember this for your exam or whatever you're doing, this is you'll be fine, right? So let's go ahead and massage this funny looking equation. Let's see. All right, so we have S Laplace of y minus 8 plus, I'm gonna factor out that 3 outside, right? Laplace. So then we're gonna have Laplace of y equals, we can factor out that 45. So we'll have Laplace, we'll have to take a Laplace transform of t. So those are just constants, so there's nothing to worry about there. So now let me go ahead and switch colors. Now that we have that, we can go ahead and evaluate, right, the Laplace, especially on the right side of the equation. So if we recognize that, right, we're taking the Laplace transform of t. The Laplace transform of t is actually 1 over s squared, because we remember with the Laplace transform, we're actually transferring over to the s world. And actually, as a matter of fact, I know that I'm uploading this video, ahead of time. I should have actually just gone into some steps, introduced, the Laplace transform table, etc. But this is just, I just want y'all to see how this problem works out. That way, y'all have an idea. But yeah, let's go ahead and work through this, right? So personally, I like to take care of that right side first. So the Laplace transform of t is actually 1 over s squared. So remember, we have that we have the constant outside, so this will just turn into 45 over s squared. So that will be that Laplace transform of the right side. Also right here we can do some manipulation. Let me go ahead and switch colors. So we see this negative 8 right here. I could just do plus 8 on both sides, bring this over. That goes away, right? So now let's go ahead and rewrite this equation. Let me go ahead and continue with red. So now we have S Laplace of y plus 3 Laplace of y, which is then equal to 45 over s squared plus 8. Now, okay, now let's look at the left side, right? On the left side, we need to factor out that Laplace transform, or that Laplace, well, the Laplace of y, I'm sorry. You need to factor that out, right? So now the way this is going to look is that we're going to go ahead and factor this out. And we'll have s plus 3 on our left side, and we'll have it equal to 45 over s squared plus 8. Now it'll be time to divide both sides by s plus 3. That way we could isolate the Laplace of y. So we're going to go ahead and do that. So we'll go ahead and have s plus 3. And yeah, so we'll just go ahead and divide by s plus 3 and s plus 3. So now let's go ahead and do this, right? So Laplace of y, we can now go ahead and do it. Actually, as a matter of fact, let me go ahead and switch colors. Going on to a new step right here. So we'll go ahead and use blue. So we'll have Laplace of y, which is then equal to 45 over s squared s plus 3. There we go. Go ahead and extend this up real quick. And now we're going to have s, or 8 plus 8 over s plus 3. So, okay, that's how that works out. So now that's how our equation is looking like right now, right? So, now let me go ahead and rewrite this over here. So we're gonna have to do some algebra here, just basically to rearrange this. That way we could go ahead and take its the Laplace inverse of this. So the way this is going to work out is that basically by some multiplication in the denominators and such, we're actually gonna go ahead and end up with a new by rearranging this and combining both fractions here, we'll now end up with 8s squared plus 45 over s squared s plus 3. So this is basically where we're at right now. That's basically what we're looking at right now, right? So with this, right, you'll be looking at this and you'll be staring at this on the exam or whatever, or on a homework problem, and it looks like you hit, pretty much, if it looks like it's done, right? But it's not. We're just getting started. So basically, this is just going to turn into a partial fraction decomposition, right? So let's go ahead and write this as a over s plus b over s squared plus c over s plus 3. So basically with this, right, where we look at this and it's for me at least it begins to click in a way. But the way I remember in school, the way I would go about this was that I would try to look at for B, right? For B, it's actually like the easiest term to solve here, right? Because at the end of the day, we're just looking for A, B, and C. That way we could complete our Laplace transform or Laplace inverse, right? And that we could have the solution to our differential equation. So basically what happens here is that for the first step, we cover up this s squared right here. We cover that up and we substitute 0. We substitute 0 into 8s squared and s plus 3. So essentially this just becomes 8 times 0 squared plus 45 over 0 plus 3. So if we evaluate that, right, we should end up with around 45 over 3, which is 15. So we have found our middle term, which is b, which we found out to be 15. So now with that now becomes a little bit easier. So then what happens here is that we're going to multiply both sides, right, by the denominator, which is s squared times s plus 3, which will get rid of this. And now we'll have, we can go ahead and substitute everything in there, right? We could go ahead and do a s squared times s plus 3 over s plus 15. Oops, my bad. S squared s plus 3 over s squared plus c s squared s plus 3 over s plus 3. So now right here, right, you could go ahead and cancel some terms, and that way we get rid of those fractions. So now what we can go ahead and do is that we can go ahead and get rid of an s right here. We can go ahead and get rid of this s squared right here, and we can go ahead and get rid of this s plus 3 right here. So now let's go ahead and rewrite this. So now let's go ahead and do this. So we have a times s plus 3 plus 15 s plus 3. Then we have plus cs squared. Now, don't forget, right, sometimes, this would happen to me a lot, when I was working on these type of problems. I wouldn't write the left side, but it's actually very important for us to be writing that left side. So now we have just the numerator, right, of what we started off with over here. So we have 8s squared plus 45. So now that's what we have right now, right? So now we've got down to this step. So now it's time to distribute, right? And I'll basically, as you can notice, right, after we did the Laplace transform and we rearranged this function, this differential equation, this just became an algebraic problem. So that's basically why this method is used, right? Because we take a funny looking differential equation and turn it into a algebra 1 problem. So we have as squared when we distribute that plus 3as plus 15s plus 45 plus cs squared. There we go. So now that's what we're looking at now. So now let's go ahead and by one of the methods that I would do this. So now let's go ahead and look at the terms, right, with the matching exponents. So now what we can do is that we can form different equations, and we could set them equal to the number or the exponent, right, of the left side. I don't know if that's making sense, right, to you right now, but you'll see it right now when I go through it. So basically we have this as squared right here, and we have this cs squared, and right here what happens is that we can go ahead and rewrite this, right, as a plus c. And now we look over here. We could set this equal to 8. And basically after that, I mean, it's just game over, right? We knocked down this differential equation because now we can go ahead and do its Laplace inverse. But let me go ahead and work this out. So basically we can go ahead now and match this right here. Let me see. So now we can have 3a plus 15 equals 0, right? Because there's no term like that, right, on the left side. And so now we knew, right, that b is an equal to 15. So let's go ahead and solve that middle term, that we can go ahead and take care of the other one. So basically what happens here is that for that term we have 3a. We have 3a is equal to negative 15. We divide by 3. A is equal to negative 5 now, right? So then we go over here, right, to the top equation, and now we can go ahead and solve this, right, because we know A. So now we have negative 5 plus C is equal to 8. So now we do plus 5. So plus 5, C is equal to 13. So basically now we have found A, B, and C. So we know that A is equal to negative 5. B is equal to 15. And C is equal to 13. So now, now we're ready, right, to go ahead and... So now let's go ahead and rewrite this step right here, this step down here, right? So let's go ahead and have A over S plus B over S squared plus C over S plus 3. So now we can go ahead and substitute this in there. So we can have negative 5 over S plus 15 over S squared plus 13 over S plus 3. Now we need to go ahead and take the Laplace inverse. Oops, I wrote it backwards. We need to go ahead and take the Laplace inverse of this right here, of this given part right here. So basically when I do that, right, oh man, we can go ahead and have so now let me go ahead and rewrite this. So 5 over S plus 15 over S squared plus 13 over S plus 3. So now we know that the Laplace inverse of this right here, of negative 5 over S, this will just be negative 5. So now we have 15 over S squared. That's just going to be plus 15t, right? Because I remember when I told you at the beginning, right, the Laplace inverse of t is 1 over S squared. So now we have that constant is 15, right? So it'll be 15t. So if we were to take the Laplace inverse of 15t, it'll be 15 over S squared. But now we're taking the Laplace inverse, which is its opposite, right? And now for the last part, right, this will just be plus 13e to the negative 3t. And this is the solution, right, to this Laplace transform. And yeah, so that's how you solve this this given problem, and that's how you use a Laplace transform with a first order differential equation, right, non-homogeneous equation. If you like this video, or if or if you have some tips or somewhere I could improve, please feel free to leave some comments. And I hope y'all like this explanation. Thank you and have a good